So we have started organometallic compounds. This is the unit from physical chemistry paper, organometallic compounds. We have seen what are organometallic compounds, their classification, nomenclature, etc. Up to this, we have seen. Okay. Now we have to see some organometallic compounds, their properties, methods of preparation, and their structure. Okay. Organolithium compounds, organotine compounds, organoaluminium compounds, and organotitanium compounds. We have to study compounds of lithium, organolithium compounds, organotine compounds, organotitanium compounds, and organoaluminium compounds. We have to see its preparation, properties. Properties means chemical reactions and physical properties, and their structure and their applications. Okay. So today we will start the organolithium compounds. The compounds of lithium with organic group in which there is direct bond between carbon and lithium is called as organolithium compounds. Organolithium compounds. मध्ये मध्ये तुम्हाला आवाज येत नसेल किंवा बोर्ड क्लिअर दिसत नसेल तर सांगा मला. ओके. So these are the organolithium compounds are nothing but the compounds of organic group with lithium there in which there is direct bond between carbon and lithium. These are called as organolithium compounds. Okay. So we have to see the preparation. This first method of organolithium compound is from alkyl halide. From alkyl halide. RCl or X, we call it as X. These are the alkyl halides. And say CH2, CH3, CH2, iodide, bromide, or fluoride. These are called as alkyl halides. Okay. So we are able to prepare organolithium compounds from alkyl halide and direct metallic lithium plus 2 Li. This reaction should be carried out at minus 10 degrees Celsius and in ether. Ether is used as a solvent and temperature is minus 10 degrees Celsius. Then we get organolithium compound CH3, CH2, Li plus Li. This is the organolithium compounds, ethyl lithium. Okay. Why we have to carry out this reaction at minus 10 degrees Celsius? To avoid Woods reaction. This Woods reaction you have studied in BSc first year or in 12th, 11th, 12th somewhere. What is Woods reaction? Woods, sometimes it is called as Woods coupling reaction. Okay, it is called as Woods coupling reaction. It is used to prepare higher alkanes from alkyl halide. If we use higher temperature, then we get such type of compound. These two combine with each other, CH3, CH2, CH2, CH3 plus 2 Li. Higher alkanes are obtained from the alkyl halides. This reaction is carried out at higher temperature. If we increase the temperature, then instead of this reaction, instead of giving organolithium compounds, we may get alkanes. So to avoid this reaction, preparation of organolithium compound, alkyl lithiums is carried out at minus 10 degrees Celsius and the solvent is used as ether. Now, aryl alkyls, for example, say C6H5 iodine, phenyl iodide. This is the aryl group. Phenyl group C6H5. Such aryl alkyls are resistant to Woods reaction. If we take aryl alkenes, then these are resistant to Woods reaction. So these can be carried out at higher temperature in ether plus 2 Li. We have to use solvent ether. This may be carried out at the boiling point of ether also. They do not undergo Woods reaction. They give phenyl lithium C6H5Li plus Li. So this is the synthesis of organolithium compounds by direct reaction, interaction between alkyl halide or aryl halides with metal. Okay. Then the second method for the synthesis of organolithium compound is by metal halogen exchange. Now these are quite similar to previous one. For example, if we have taken this one, benzene ring, para-bromophenol, okay, plus it is called N-butyl lithium. It is also an organolithium compound. Okay. So the reaction name is given metal halogen exchange. So in this reaction, what happens? The metal is exchanged to this one, and we get OH, this Li plus C4H9 Br. We get N-butyl bromide and this lithium phenyl. Okay. So in this way, this bromine gets replaced by Li, exchanged by Li. So this is called metal halogen exchange reaction. In this way, also we are able to synthesize organolithium compound, but from one organolithium compound, we have prepared another one organolithium compound. Okay. Similarly, if we take pyridine, this is a pyridine. This is Br2-bromopyridine plus, say we take butyl lithium. Same product we get, that the bromine gets replaced by Li, and we get this compound. This is the second method for the synthesis of organolithium compounds. Okay. In the same way, some aryl, generally aryl or allyl, these are the aryl aromatic ring. It has aromatic ring, so these are called as aryl lithiums. This pyridine ring is also aromatic. This is also aromatic. Okay. This N-butyl is alkyl. Okay, so this is alkyl lithium. So aryl lithiums can be prepared by metal halogen exchange from alkyl lithium. Okay. Then if we take allyl compounds, say C2 double bond CH Br. This is the allyl bromide. We may say call it as a vinyl bromide. This is the allyl compound. This is the allyl one. This is not aromatic, unsaturated but straight chain. These are called as allyl. When it is treated with same N-butyl lithium, then we get allyl lithium CH2 CH Li plus C4H9 Br. So this is the second method for the synthesis of organolithium compounds. Okay, in this way also we are able to prepare organolithium compounds. Third method is metallation by phenyl lithium. Third method is called as metallation. For example, we have 2-methylpyridine. This is a 2-methylpyridine. Okay. When it is treated with phenyl lithium, it is treated with phenyl lithium plus C6H5Li. Then we get this metal attaches here, and we get phenyl group. We get benzene plus CH2Li plus C6H5. So we are metallating this 2-methylpyridine. We are metallating this 2-methylpyridine by using phenyl lithium. So this method is called as metallation by phenyl lithium. For this metallation, this group must be active one. This group must be active one. Okay. For example, if we take cyclopentadiene, this CH2 is the active methylene group. This is the active one. Okay. When it is treated with phenyl lithium, C6H5Li, we get cyclopentadiene lithium plus benzene. So we are metallating this group. So it is called as by metallation with phenyl lithium. Another example, if we take the ether, aryl alkyl ether, say methoxybenzene. OCH3. Then it is treated with C6H5Li. We get OCH2Li plus C6H5. In all these cases, the lithium from phenyl group gets attached to the active methylene group. This is the active group. Active methylene group means CH3, CH2, whatever may be that group, should be attached some electronegative group or some aromatic system, so that the negative charge formed here that can be stabilized. Okay, so these are the methods for the synthesis of this is not such one. This position is okay. So these are the three methods for the preparation of organolithium compounds. In other group, many more methods may also there, but we have to study only these three methods. If question is asked, then you may give any two methods out of these three methods. Okay, is it clear? Is it clear to all? Okay. जर मध्येच आवाज फुटत असेल तर सांगा मला, म्हणजे थोडा वेळ थांबता येईल आपल्याला नेटवर्कसाठी. आवाज येतो ना क्लिअर? हॅलो, बोलत जा.
Yes, sir.
Okay. Now we have to see properties of organolithium compound, physical as well as chemical properties. Okay. So these organolithium compounds or the lithium alkyls are solids. They are with low boiling points. Their boiling point is low. These are solids, or sometimes if temperature is somewhat higher, then they may be colorless liquids. So they may be solids or liquids. If they are solid, then their melting point is lower. Organolithium compounds has low melting points, or these are the colorless liquids. Okay. Now you might have studied Grignard reagent and MgX. You have studied this in the 11th or 12th somewhere. Grignard reagent. From the Grignard reagents, we are able to synthesize almost all classes of organic compounds. By using Grignard reagents, they are able to prepare alkenes, alkynes, ketones, aldehydes, alcohols, acids, cyanides, nitro compounds, amines, whatever there are the classes of organic compounds, all these compounds can be prepared from the Grignard reagent. That's why there is a Nobel Prize for the invention of this Grignard reagent in the field of organometallics. We have seen in our first lecture that up till now, 5 Nobel Prizes were awarded for the research in organometallic compounds. These organometallic compounds are most important in synthetic organic chemistry, in catalysis, in medicine also. Okay, so these classes can be prepared from Grignard reagent. Same way, all the organic compound, all the classes of these organic compounds can be prepared from our organolithium compounds. Now, what is difference between these two? These organolithium compounds are up to 100 times more reactive. These are 100 times more reactive than the Grignard reagents. Organolithium compounds are 100 times more reactive than the Grignard reagent, as the carbon and lithium bond is more polar as compared to carbon and magnesium bond. Because the electronegativity of this lithium is less, carbon is more. The electronegativity magnesium is somewhat more electronegative than lithium. Because so this bond is more polar than this. Because of this, these organolithium compounds are more reactive than the Grignard reagents, up to 100 times more reactive than the Grignard reagents. Okay, so these organolithium compounds are preferred for the synthesis of many more organic compounds. These organolithium compounds are soluble in organic solvent. Organolithium compounds are soluble in organic solvent, whereas insoluble in water. They are insoluble in water. They have highly reactive, the bond is highly polar. Okay. So this reacts with water. Organolithium compounds react with water. What would be the product when it reacts with water? Rli plus H2O. This H2O can be written as HOH. This dissociate in this way, H positive, OH negative, is it? Or its dissociation depends upon strength of this reactivity of this one. Reactivity of this one. So we get RH plus LiOH. We get alkane when organolithium compound reacts with water. Okay. Now, if we take formaldehyde, HCHO, it is formaldehyde. When it is reacts in an acidic medium, H plus, then we get the primary alcohol. We get primary alcohol R CH2OH. These same reactions are in case of Grignard reagent also. When Grignard reagent reacts with water, we get alkane. When Grignard reagent reacts with formaldehyde, we get primary alcohol. Okay. When Grignard reagent reacts with other aldehyde, other than formaldehyde, we get secondary alcohol. If in place of this H there is R, then we get secondary alcohol this type of. Is it? When it reacts with ketone, we get tertiary alcohol. We get tertiary alcohol, and its reactivity is much more than the Grignard reagent. Okay, these are more reactive than the Grignard reagent. So this is the somewhat reactions, 3 to 4 reactions of Grignard reagents. Okay. These are less susceptible to steric hindrance also, because there is simple R group right here, the CH, H and L. Such type of bonding is there. Okay, there is no any other group attached to this lithium or this carbon. Also, there is not crowding of atoms around this one. There is not crowding of atoms around this one. That's why they are less susceptible to steric hindrance. Whereas in place of MgBr, bromine is there, etc. So these are susceptible to steric hindrance. That's why the reactivity towards this one is much more. Okay, so when these also react with the some sterically hindered ketones also, these are the simple one. For example, if we have taken CH3 twice CHLR, CH3 twice CHLI, it is we may say isopropyl lithium. It may be called as isopropyl lithium. Okay, when this reacts with say CH3 twice CH2 twice, okay, CH3 twice CH2 CH twice C. If we write structure of this compound and this compound, then there would be somewhat crowding of atoms. This can be written as CHLI, CH3 like this, CH3. Okay. This is isopropyl lithium. Plus, this compound can be written as say C double bond O, CH, CH3. If I write hydrogen separately, then there will be more crowding. CH3, CH, CH3, CH3. Here, there is crowding of atoms around this lithium also and around this carbonyl carbon also. दोन्ही ग्रुप भोवती खूप atoms आहेत, गर्दी आहे atoms. ओके, दॅट इज कॉल्ड स्टेरिक हिंड्रन्स. या गर्दीमुळे काय होते, काही रिएजंट्स इथपर्यंत पोहोचत नाहीत किंवा ह्या कार्बोनिल पर्यंत पोहोचत नाहीत या आजूबाजूच्या गर्दीमुळे. That is called steric hindrance. So these organolithium compounds are not susceptible to steric hindrance. These are not susceptible to steric hindrance. Okay, they directly attack on this one. We may write now these organolithium compounds attacks on the carbonyl carbon of this one. Carbonyl carbon of this one. Around write simply now the R for this group and R dash for this group. Okay, so C R R R dash means this group. Okay, R means this group, two R groups. This is bracket is twice This R means CH3 twice CH. Okay, I will write this one. Don't make confused. CH2, CH, CH3, CH3. It is also CH, CH3, CH3. It is also CH, CH3, CH3. This is O, Li. Okay, so in this way, it can be attacked. This is lithium, this alkyl group negative is attacked on this positive carbon, which are sterically hindered, Okay, so after hydrolysis, we get alcohol. After hydrolysis, we get alcohols. Okay, so these are organolithium compounds. One more advantage of these organolithium compounds are these are not susceptible to sterical hindrance. Whereas grignard reagents are susceptible. Grignard reagents cannot react such sterically hindered positions. अशा गर्दी असलेल्या ठिकाणी grignard reagents reacts होत नाही. Okay, then these reacts with alpha beta unsaturated compounds and gives 1,2 addition. This reacts with alpha beta unsaturated compounds. Then this adds or this reacts with alkenes. Say for example RELI plus alkene, CH2 double bond CH3. These are the alkene. They add across the double bond. And always addition is at terminal position. So we get R CH2 CH2 CH3. R CH2 CH2 CH3. Okay. So in this way, these organoalkyl compounds add across double bond. Actually, it is the hello. Like attached here as R negative here only. Then in this shape that is replaced by hydrogen. So these are some reactions of organolithium compounds. Then माइक कोणाचा चालू आहे दुसरा आवाज येतो त्यातून reaction with alkyl halides organolithium compounds react with alkyl halides and we get higher alkane plus lithium ion. Then the lithium alkyl reacts with water to give alkanes. Just we have seen reaction with water, they give alkane RLi plus H OH. We get OH.
नाही याला जोडते ना जोडून ठेवा म्हणजे निष्ठत नाही पिवळं मोठं आहे ग हो पिवळं मोठं सगळेच मोठे आलेत ना मग काय करू सांगा आपण पिवळेच घेऊ
माईक कोणाचं चालू आहे माईक बंद करा केलं का ओके दुसरा तुमच्याकडचा आवाज येतो इकडे so this reacts with water to give alkanes then organolithium compounds reacts with carbon dioxide to give acid just like grignard reagent RLi plus CO2 when this reacts with carbon dioxide we get acid after hydrolysis say I write simple here R C double bond O O L C double bond O O L R is attacked on one of the C double bond O Then after hydrolysis, when it is hydrolyzed with acid, then we get C double bond OH acid. When it reacts with formaldehyde, we have seen we get primary alcohol. When it reacts with other aldehyde other than formaldehyde, then we get secondary alcohol RELI plus HCHO. We get RCH2O Li. When it is hydrolyzed, we get RCH2OH, primary alcohol. When it reacts with formaldehyde, just like Grignard reagent. When it reacts with other aldehyde, say acetaldehyde, then we get RCCH3HOLI. After hydrolysis, we get RCH3OH, secondary alcohol. Okay. When it reacts with ketone, we get tertiary alcohol. When it reacts with carbon dioxide, we get acid. When it reacts with carbon dioxide, we get carboxylic acid. So these are some reactions of organolithium compounds. These are some reactions of organolithium compounds. ह्या झाल्या रिएक्शन्स. जर विचारलं तर कुठल्याही 2 किंवा 3 लिहिता येतील तुम्हाला. ओके. Now we have to see the structure of this one. In this, say there is CH, H, and Li. Simple. Instead of L, H, there will be some other group. In this organolithium compound, carbon is sp3 hybridized. Carbon is sp3 hybridized. So it has 4 sp3 hybrid orbitals like this. चार sp3 hybrid orbitals असतील having unpaired electrons. So with 3 hydrogen overlaps or some other carbon is that is the ion, and is this remaining one that is overlapping of lithium, as the electronegativity difference between carbon and lithium is much more. लिथियम ची इलेक्ट्रोनिगेटिविटी खूप कमी आहे कार्बन पेक्षा. दोघांचा इलेक्ट्रोनिगेटिविटी डिफरन्स खूप जास्त आहे. ओके. So because of this bond is more than 100% ionic character. Is more than 50% ionic. So we call it as the ionic bond. This bond is much polar. A bond खूप polar, that is we call it as ionic bond. So such type of bonding, such type of structure is there in organolithium compounds. Lastly, we will see its applications, then we will stop. Now, what would be the applications of organolithium compounds? Mostly these organometallic compounds are reagents in organic synthesis or catalysts somewhere. So these organolithium compounds are used as reagent in organic synthesis to synthesize various classes of organic compounds. So organolithium compound can be used for synthesis of alkane, alkenes, alkynes. Just before I have told you, alkyl halides, alcohols, ethers, aldehyde and ketones, carboxylic acids, say dithionic acid, sulfuric acid, and some other organic classes, cyanides, amines, nitro compounds, etc. Almost all classes of organic compounds can be synthesized from this organolithium compounds. Okay. So till now we have completed the organolithium compounds. In our next lecture we will take organoteam compounds. Okay. कोणाला काय अडचण आहे ह्याच्याबद्दल? काही डाऊट असेल तर विचारा. सगळ्यांना समजलं?
येस सर.
ओके, ह्याच्या नोट्स मी तुम्हाला 2-3 दिवसात टाकतो व्हॉट्सअप ग्रुपवर.
ओके सर.
आपण थांबूया तिथे. हा बोला बोला, कोणाला काय डाऊट आहे का? नाही ना? ओके.